Hello again, it is that time of day for Odinmade Hero. The series where I learn from Casey Muratori as he programs Handmade Hero in C and C++ while I do it in Odin. So yesterday we had a pretty productive day. There wasn't too much chaos. Well, there was a little bit of chaos with me not correctly identifying a bug or the cause of a bug that should have been obvious based on something that I myself observed beforehand, but I just did not connect the dots yesterday. That was not so great. But there was one thing that I was harping on. In fact, did I actually... I don't think I... committed this code for day 62, so let me go ahead and do that. Day 62, what was that? I actually can't remember. I just did it. I actually updated the title of yesterday's stream. Basic moving projectiles. And that's exactly what we were working on. We were focused on getting this sword to be throwable. I've got a hair stuck in my keyboard. Ew. Get out of here. So now we can drop in our hero here, and we can sling rocks, or swords as the case may be. You know, at some point we'll have a sword sprite. We can actually throw swords, although I don't know why you would throw a sword. Maybe like a dagger, you know, or a knife. But throwing a sword just seems not like the thing you want to do in general. I don't know. Sword throwing, it just seems like an inefficient way to fight for your own survival, but I guess it's really irrelevant to the topic at hand, right? So, yeah, we worked on that, and there was something that I was bringing up again. It had come up when we were still in the thick of the spatial partitioning and the rest of the kind of world chunk, embedding entities into the world chunks of the game world code. Just being in the middle of all of that, I believe, where was that? Was it in change entity location? I think it might have been here. Or, well, if we just go back to where the player is added and then polled. So this is the issue that I was talking about, right? If we don't have a player and then we add it in, I was talking about how for whatever reason, the player entity's location and world chunk coordinates was flip-flopping along the x-axis between 0 and 1. And I was able to prove that by just printing out the player's location during this loop to handle the game's input, you know, and pass it to this code here, which just updates the player state, right, including the state of the sword that the player may or may not be throwing, sword or rock, as the case may be. And I think so. This is for the sword, so we don't care about that. But it was like specifically before and after move entity. I think I was seeing different results, right? And then I just decided to, after the end of yesterday's stream, print out the controlling entity, in this case the player, right? Printing out their low position here, and then just seeing what happens after we drop in. And it was at that point that I observed that bug just seems to be gone. I don't know exactly what change fixed it or when it was fixed, you know. Both of those things are escaping me because we made a whole bunch of changes when I, you know, compared to where we were when I first identified that. I can't even remember if that was, you know, in the middle of last week, the beginning of last week, or 2 weeks ago. But you can see here now we are consistently on the chunk, on the 0, you know, coordinate for the chunk X. I guess one thing I could do is throw a print before the move and see if it's different before and after, like if it goes from 1 to 0 before and after every move entity call. But I don't think so. And if we run it again and print out, that bug just seems to be gone. So I was worried about that for nothing, but I wanted to see if it was still there, really, because I didn't want to keep, you know, bringing it up and being like, I should really take a look at that and see what's going on. It must have been something that was just kind of in flux that got fixed naturally over the course of us refining all of that world code. So with all of that out of the way, I think we're in a fine state. You know, we've been running into basically the same exact issues that Casey is. It was just there's a bit of confusion there with some of the different bugs that I was creating for myself by just translating things wrong or doing things ever so slightly differently, like with the allocator stuff, right, where we are now pulling the arena allocator out of the context and then passing it by reference when we know we want to allocate a new world chunk if we don't find one. Stuff like that. There was just a little bit of minutia that was confusing things further for me. But long story short, we're good to go. We're going to kick off day 63 here, where Casey's going to start talking about simulation regions. And actually, I wonder how much blackboarding this is going to be. It looks like it's going to be quite a bit of blackboarding, so we'll sit back and learn some stuff for the first 20 minutes or so, and then we'll get into some code. So here we go.
All right, hello everyone, welcome to Handmade Hero, the show where we code a complete game live on Twitch from scratch, no libraries, no engine. And today is kind of a good day, I think. We'll have to see how it goes. You know, you never can count your chickens before they hatch. Sometimes they hatch into little stillborn chicken fetuses, and that's no good for anybody. But what I will say is, you know, like I said when we started this, I was like, one of the big things that we're doing here is we're trying to put enough code down in sort of like a primitive form that we can tell how everything should be structured. So that when we go and we start writing individual pieces that are meant to be shippable quality, we don't fall into the standard trap of over-designing, under-designing, designing the wrong thing, doing all the sorts of things that happen when you don't write the usage code first, right? I've said that many times, always write the usage code first, and it's very important. So that's what we've been doing, and the entire time that we've been doing it, I've been looking at some more advanced features in the entity stuff, the low and high frequency set thing, and being able to scale to large numbers of entities and that sort of stuff. And so that's something we wanted to do, but it was never quite clear exactly how we could architect the code to make that work nice and cleanly. But that was okay for me because, like I said, the important thing is to get enough code down that you can see, and slowly over time, good solutions to how you want to do things architecturally kind of work their way up from the code that you have down there. And so it's really just a matter of sticking it through and doing enough sort of trying of things that you want to accomplish to get to the point where you can actually do it. And so after the stream last night, I was lying in bed, and normally I'm not super good at falling asleep. So typically what happens is I'll like go to bed, and then I'll just get up like 30 minutes later because it's pretty clear that I'm not going to fall asleep, and then I'll do some stuff for a while, and then I'll go back and try to fall asleep again later. So I was lying in bed, and what I realized is I finally realized, I think, the crucial thing that with the high and low frequency stuff that can make it into a nice clean architecture. And so I want to talk a little bit about that. Because I was pretty psyched. I was like, yes, this is the thing that I've been waiting to sort of see click in a good way. So what I realized is, and what day are we here on Handmade Hero? We're day 63. So what I realized here on day 63, right? Or I guess this was day 62 when I realized it. But I realized we have two constraints that are coming together, right? We have two constraints. The constraints are, number one, we want a extremely large world, right? So we want to be able to handle worlds that are so large that floating point accuracy would immediately degrade if you were to try to store them all as single floats, right? So we wanted to say that our engine could support that. Again, not because any particular engine has to support that, but rather because we want to show how you handle it in code, because it is something that does come up if you want to do large worlds and you want to do them right. So I wanted to put that in there. We had another thing, which is extremely large entity counts, right? So we basically have two scalability things that we want to talk about. One is about float precision, right? And one is about basically about processing power, if you will, right? This is about processing power. The problem with extremely large worlds is that we will run out of precision in a 32-bit float to deal with them if we just did everything in float and said, hey, whatever, anything goes. The problem with extremely large entity counts is that we don't have enough processing power to basically just write code where we write the code for every entity and then just run all the entities in the world all the time. That will never scale to very large entity counts. So we have two competing concerns here. And what I realized is I was not thinking about them together. I was not thinking about how they related to each other. I was implicitly dealing with their intersection, but I wasn't thinking about it overtly. And so what I realized is that if you think about it overtly, I think that shows the way to doing the good architecture that handles both of these things, which is our goal in this design process, right? So let's talk about that. What does this float precision thing make us do? If we don't want to just use doubles, if we don't want to just go to 64-bit floating point, which there's a number of reasons we don't want to do. A, they're half as fast. B, there's platforms that don't support them at all natively. C, we don't actually necessarily even need that much precision, blah, 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 blah. There's all sorts of reasons why it might not be a good idea to strictly go to doubles, right? But the real big one is just the performance, right? We know that we're going to be half as fast if we did that. So we'd like to make sure that most of all of our stuff that's happening, all of the computations that we do for everything, we'd like to be able to do those at full speed. We'd like to be able to do them in float so that we can be fully 4 wide on 8 wide or 16 wide on SIMD instead of 2 wide, 4 wide, or 8 wide on SIMD, right? So we get basically twice the performance if we're in float. So what we want to do is we want to be able to do, we want to be able to live in that world, right? We want to be able to live in that world. But what that means is that whenever we do our calculations, if we're doing everything in float, we have to be doing it around some origin point that's local, right? So what that means is if we have people everywhere in the world, right, and this is the giant world, let's say, right? This is the giant world. If we're looking at the giant world and we say that we have all these entities that are like over here, right, and we want to talk about how they work, in order to process them all, what we do is we first pick a local origin. And what we were using was the camera for this in our current code, right? We would take the camera and we just figure out where everyone was relative to the camera, right? So if you imagine what happens, we're taking a little slice of the world, right? And we're saying wherever the camera is, we just say where the entities are relative to that camera. And then because we know that's a very small neighborhood, right? That's only, a few meters across. We're talking about like a 50 meter by 50 meter square, right? Whereas this might be like hundreds of kilometers or something. Who knows? I don't remember what we calculated it, but this is huge and this is tiny. This is not a problem for float precision. We have plenty of precision here and we can do our calculations in float, no problem, right? So what this implies is that we're always doing these calculations, right, in a local neighborhood, okay? And so that's what led us to the whole, we had low frequency and we had high frequency entities, right? And what we were doing there is we were saying we were storing basically like an extended detail version of where the entity was that involved tile positions, right, like a tile chunk position, and an offset, right? So we were basically storing, and alternatively, like again, if we were on machines that support doubles, we could store doubles here. But basically we had like the slow version of where people were in this low entity, right? But the high version of where they were was just in a vector 2, right? It was a vector 2 float. So basically this gets translated to this and we would do our calculations here. But then we kept having, I don't even want to say problems necessarily, but you could tell even just from an early standpoint that there was just a lot of fussing involved in us having to think about which state we were talking about, whether it was this position or that position, and keeping these two things in sync and all this other nonsense. And it was really just a drag on the coding, right? So there's that. But there's another problem, and there's a problem that we hadn't actually gotten to yet, but that we sort of were setting up to deal with, which is the scaling to extremely large entity counts. And basically what that was saying, okay, so there's low frequency entities and high frequency entities, right? All of the entities always exist in the low frequency set, essentially. They're the data that actually describes the entity. And then there's this high frequency version of the entity that we actually use for processing that has some additional stuff in it, right? And that's how we were handling this. And what I said was, well, we're going to want to be able to do processing on these low entities because we want things in the world to keep happening even when you're not around it. So we want to be able to sort of have people who are maybe, like the example I gave was, let's say there's like a creature or a guy who's like going to go somewhere, take something from a location and bring it back, I don't know, to his lair or something. Who knows? There's something going on out here. And we want that to kind of keep going on because it might be nice, give the world a nice emergent feel when the player comes upon this and sees that like all of the apples are missing from here and they go to this little apple thief and he's got all these apples in his back room, or I don't know, picking stupid things, but you know what I mean. You want to be able to see that sort of thing happen. And furthermore, if you came right here and watched, you would see this guy come back carrying an apple and all that sort of stuff, right? We want to support those kinds of things because again, hard to program, ergo, we want to show it on stream because the whole point here is to learn how to do advanced programming techniques. So what I said was, well, we'll have the low frequency set, and then what we'll do is we'll just operate on this low frequency set at a lower rate, and then the high frequency set will be where all the magic happens, so things that are close, that are in the camera view get the high frequency detail, and so on and so forth, right? But in the back of my head, I was really worried about this, because I'm like, well, now we have to write every entity's code twice, right? We have to write, like, code that works for when they're high frequency entities and code that works for the low frequency. Like, that doesn't sound very good. I don't really know what to do about that. It seems like there's going to be a lot of work there, and it just sounded bad, right? So that was worrying me as well. So all of this stuff was kind of built up. So what I realized when I started was sort of not even really thinking about it, it just kind of like must have been a background process in the brain, was I realized that that was exactly the wrong way to think about the low frequency entities, right? Thinking of range-based processing of them was just plain dumb. That was dumb. There was really no reason to think about them in terms of index ranges, right? You remember I even said it on the stream. I was like, let's go ahead and we'll just process like 1,000 of them at a time or something, right? That doesn't make any sense. Why would you do that? That is what would cause you to have to write things that operate directly on the low entities. Instead of doing that, why not just basically have a second camera, right? Have a second camera that just moves around the world, simulating the pieces of the world in chunks, right? So that every frame you do 2 camera things, basically, right? You do the ones for where you can see, which should always be simulated, and then periodically, at a lower frequency, you will basically sweep through all the other parts of the world, focusing the camera on them, the virtual camera in this case.
Okay, so I watched him do this whole little lesson here on the blackboard way back when, right? And it didn't really click at the time when I was watching him explain that, even after having written all this code. But today it does. Like, instead of doing what he just said, right, where you're iterating through all of these low entities, you're actually just pretending to set a camera. You're not actually showing the player that section of the world, but you're simulating as though you were playing in that corner of the world, so that all those entities can have their updates happen, and then you just kind of move through the entire world periodically that way. And that's, never mind all of the confusion and I don't know, like he was just pointing out with the trying to handle the coordinate differences, like what aspect of the entity is stored in the low set versus the high set. Like I still don't have a good intuitive sense for that. I think I can just like off the top of my head say, right, like if it's a high entity, then its position is just relative to whatever the camera is. But the low position is a little bit weirder because I think we're still packing the value of the specific tile and then the offset of the tile into that world position. Or maybe not, because we got rid of the chunk dim stuff, if I'm not mistaken. Or the chunk, not the chunk dim, but the chunk shift and the chunk mask stuff a while ago. So need to go back through that code and make sure I really understand what's going on there at some point.
Map all the things into the high entity space, do the processing, map them back to low, right? So basically, what that means is now we can get rid of the concept of ever operating on a low entity at all, right? You will never touch a low entity. There's never any reason to, right? It's strictly a storage format, which is what I kind of wanted when I started, but I just couldn't figure out how to do because of this dumb thing, right? It's like, I would have rather had it so that, I would rather have always thought of low entities as just like a compressed or like an archival format, right? For my high ones, they map into here and they sleep in this state, right? And then they map back. That's how we would do it in a normal game that wasn't trying to simulate things anywhere, right? That was doing something simpler than what we're trying to do here. We just compress the high entities or map the high entities back into here, and some of it's not compression, some of it's actually expansion, like it's storing it in this more detailed format for the position, for example, right? But in general, you know what I'm saying? We archive them to low, and then we bring them back from low into high when they come back on the screen. That's what we would normally do. And so the thing that was causing me all the problems, though, was I was like, we can't really do that because we want them to still be live. Well, we can. All we have to do is just always use regional processing. I don't know why I didn't think of it before, but that's just the way programming works. And it's the reason that I say to always do things by writing the code first, is because you need to give yourself the time to realize things. They're always going to be obvious in hindsight, but if you don't get the stuff out on the page, right, or in the editor, I should say, and you don't have some time to look at how it's actually working in reality, you're never going to be able to have those insights because you just don't have the information you need. And so this leads us to what I think is a very good way of structuring this, and we're going to start on it today. I don't think we'll finish because we have some restructuring to do. But basically what it's going to be is you never touch low entities. So low entities are never switched. They're a storage format only. Right? So what happens is we have a new concept, basically. I don't know exactly what we'll call this, right? But we'll basically say there's a simulation region. Okay. And again, this is exactly what I was talking about when I say engine architecture. You do it by seeing how things go, and then you pull up from there. And that's exactly what we're doing. We're looking at what happened, and we're going, now I can finally see how things are supposed to work. Now I can really see a very important piece of my architecture come to fruition. So what we'll do is we'll have this thing called a simulation region. A simulation region is a rectangle in space, just like we sort of had already with the camera, right? But it's completely self-contained in the code. So it stores a high entity list for itself, right? It stores its bounds, and it's got a very well-defined beginning and ending, right, in time, in the code. So we start it, we map all of the entities into high for that, we run the processing, and then we map them all back to low, right? So basically, this is an entirely self-contained thing in the code, a simulation region. You can do them anywhere you want, and you can do as many of them as you want, and they come and they go, right? They never persist across a frame boundary ever, right? And if we ever wanted them to persist across a frame boundary, that would be an optimization. So basically, that would be something we'd add after the fact. So that means now we don't have to write two pieces of code. All the pieces of code for simulation always happen exactly the same way, right? Always exactly the same. So that totally simplifies our life quite a bit and gives us one of our key architecture components, assuming, again, that it works out when we go try it. And so this is basically like, this is a key component right here. That all makes sense? Hopefully. So again, not terribly different from what we've been doing. It's very similar, but it organizes all of the pieces properly so that the problems that we were having with our current system don't happen anymore, right? And basically, no one ever looks like we have these problems with moving entities, writing back to the low, and all this other stuff. All of that is now totally gone because everything only happens on high detail entities, and only at the very end are things all written back to low as a storage format only. And I really like that because that to me seems really, really pretty darn good.
Wow. Yeah. There's just something different about this time around. Maybe it's just having gone through it twice, because there's so many other things that you're thinking about. And on the complete other hand, I was just trying to burn through as much as I could because my time was so limited, and it still is so limited today. But something that I kind of forced myself to do, especially streaming this experience of trying to learn from Casey, is to try and take it slower, at least to the extent where you have a little bit of a better intuition for what's actually happening. But this really clicks this time, whereas before. It just felt like I couldn't see what he saw as being so valuable, but like he's saying, no longer having to deal with, are we dealing with the low coordinates or the high coordinates? Like that's all just kind of made opaque essentially. And then the only thing that you care about is whatever the, high entities attributes are. That's what you're going to be working with regularly in the code. That definitely helps with the confusion of high versus low at all. And it's like you just pointed out, the experience of actually writing the thing and doing the thing, and then being able to look at that in retrospect and identify like what is the essence of what is happening here and how can I solve that as elegantly as possible. I've had lots and lots of experiences like that where I wrote something very terrible, where maybe it was like multiple, and this is the best analogy I can come up with just because it's the only experience I can relate this to, is working on, like, let's say, having like 3 to 5 different database transactions across one API call and then figuring out how to make all of those transactions happen at once. But it's hard to write that single transaction out of the gate because you can't even identify necessarily the order of events that everything needs to happen in. And I've just never done, I don't know how anybody else does it, to be fair. But it's never been my experience that people are really diagramming out what they're going to write in code, because it just seems like that would be a very unnecessary step. But maybe that was very prevalent. Maybe it still is prevalent in some circles, maybe specifically within games, programming circles. I know there's just all sorts of things that you can get lost on in the weeds with, of just like pontificating about what it is you're going to do rather than actually doing it.
Okay. Now there's one thing I want to mention, which is like sort of the slight wrinkle, which has nothing to do with this exactly. We would have had it in the other system as well, but something I just want to kind of point out, because I think we gotta design in some, what's the word for it? Affordances for it. One thing that we never actually dealt with, and I think we can deal with it pretty easily now, is that in the past, when we map things into our active region, let's say this is the active region here, this dotted line, then we have entities, right, in the world. Here's some entities in the world, and here's some more entities in the world. If we simulate all of the entities in this region, we have a problem. And that is that entities near the boundary may be allowed to move outside of the boundary, because on their time step, they'd be able to move across that boundary, and in crossing that boundary, right, they will not collision detect with any things that were outside of the boundary. An entity that was right here, or right here, would never have been brought into the high frequency step because it's outside of that boundary. So what we need to be able to do is we need to be able to say, okay, simulation actually happens inside a conservative boundary that is less than the 1 frame movement distance away. I'm sorry, it's more than the 1 frame distance movement away from a secondary boundary, which is where everything gets pulled in. So this outer boundary is basically the high boundary, and this is like the sim boundary. So things in here get simmed, things in here get pulled in but not simmed. So they're just standing there as colliders in case something tries to go out there and hit one of them, right? But they themselves are not allowed to move, right? At least not in this simulation pass. Does that make sense? They could still be active entities, and they still could be simulated by something that went and did another simulation region that was right here or something like this, right? But what we want to do is make sure that we essentially don't ever have that case where something could go outside of where it needs to go, right? Where it's allowed to go. So there's another thing to think about. All right, so I hope that all makes sense. I'm going to go ahead and start the process of making that happen. Like I said, that's going to take a little bit of reorganization, which tends to be a little slow when we do it on the stream, because as I explain things, right, there's a lot of text moving around and doing stuff that maybe makes things a little slower than it would be if we were just going to reorganize it flat out. But even so, I mean, even when you're just programming not on the stream, it does take a while to do all the text shuffling and stuff that's necessary inside a reorganization, right? So that's worth noting. It's never really that fast to do. So it's going to take a little bit of time, but I think it's definitely the right thing to do.
Hopefully this isn't too painful. It's whenever like a heavy restructuring of the code happens, and we've done a lot of that with all of this entity business in the world code as well. It tends to lead to me making like one subtle change that is incorrect, and then I have to like go back and be like, okay, what the hell is causing this new bug that wasn't there before, but just because we're restructuring things, it kind of surfaced. So it's not like it's a flaw with the design. It's just, it's tough, and every single time it happens, I'm like, well, you'd probably catch stuff like this a lot sooner if you set up a debugger and stop being lazy. But I'll get there. We'll make the time to do it. I just don't know. Part of me is just torn on whether I actually want to do that exploration of how to figure that out on stream, because it could easily just lead to me doing 4 hours of streaming for no good reason. It probably makes a little bit more sense to just like figure out how to do it, and then I can talk about it a little bit on stream. But then I have to find the time to do that outside of stream. You know, it's like a catch-22. I don't know how to allocate the time to where I get the end result that I want, but we'll get there.
So I'm going to go ahead and just flat out start that process, get us into a position that does exactly what I just said, because we already have all the usage code written, essentially, that should guide us and allow us to know that we have all the stuff that we need to support it. So, first things first. Let's go ahead and say that we have a handmade simulation region. I like that name. It seemed good enough to me. And so we have a handmade simulation region. Well, I don't actually need to call it handmade simulation region. Simulation region will be fine. I guess I could call it sim region, but I don't know. Okay, all right. We'll call it sim. We'll call it sim region. No need to introduce extra characters for no real reason. So let's call it handmade sim region. That's good enough. All right. Struct sim region. And a sim region is what I'm going to do basically is I'm going to move the stuff that used to be fast and loose and kind of always existing in two places. I'm going to move that over to simulation region. So basically this over here is going to look like that, right? And I'm going to call these just flat out entities, because everything's going to work on these entities primarily, right? So we're going to have an entity count.
Kind of, whoa, doing weird things with Windows now. So I kind of want to just move away from doing things this way, because when I have to pull code, I can't just copy and paste the code like he did. I have to be like, okay, like what are the types that have to stay in here? And you know, it's a consequence of of the design not being 100% locked in at this point. And I don't know, I kind of like that I don't have to keep on writing the same thing over and over. But then again, like, is it really that big of a deal if it saves me? It's like, do I want to spend the time now or later to to deal with this? So we have the entity count, and what's kind of weird about this actually is that, okay, so he got rid of the notion of a high entity count, and now it's just entity count, and then we're just going to have entities in a sim region, and they're going to be high entities. There's going to be a max of 256 of them, so the same thing is here. But will we get rid of that notion of, oh, whoops, locked my computer. That was smart. So yeah, we'll see if these type names change from like just regular entity or dormant entity, that sort of thing.
Now I'm going to get rid of this cap here, this entity cap. I'm going to say that we just have a pointer, and the pointer points to however many is in this entity count structure, right?
Okay, so that's going to make things a little bit different, because I don't want to use a pointer, right? We're going to use a slice, so yeah, we'll just see how that goes. But I'm hoping that the little bit of confidence that I've acquired using Odin slices will not have just vanished, having not had to think about them for a while now.
I might say that we also have a max entity count that can exist here, so maybe there's some headroom on this when we actually make it. I'm not sure that we even need that, but we'll just leave that there for now. Okay.
And I don't know if we really need that, because if this is just going to be, like, if there's no limit here, and we have bounds checking on the slice, then, you know, it just kind of seems superfluous, but we'll see. Do we need max entity count? That's all I'll do right now.
So, that's our sim region. None of these other things are particularly relevant to the sim region. But now what we know is we kind of have this, we've got this sort of set camera call, and what I'm going to do is I'm going to say that this is going to get broken up now, right? So instead of a thing that goes through and looks whether things need to get mapped out of the high frequency space into the low frequency space, this offset and check frequency by area thing, that's now no longer on the table, right? Everyone gets mapped in and out of the high frequency space every frame. That's just how we're going to do it. And like I said, if it turns out that that's too slow, then what we'll do is we'll go ahead and we'll optimize it later as a separate thing that we do. But there's no sense in basically premature optimizing that at this point. So in our sim region, what I want to do is take that offset and check frequency by area call, right? Offset and check frequency by area call, and take a look at that. And you can see that basically all that does was it was moving things, packing things into low entities as they went. But that's really, you know, it's really pretty basic. So really all we have to do is just make, I don't even really need to cut and paste that, right? It's super, super simple. There's really nothing to it. All we're doing here is saying like end simulation region or something, right? End sim region. I guess we could just call it end sim. right? And that takes the sim region. Okay, and then when I do that end sim, I'm going to loop through all the entity count. I'm going to take this. I'm going to say for each entity, right? So I've got an entity index here. For each entity that's in the region, I want to map that entity out and into the low space, right? So right here, again, we'd have that high entity, right? And I guess we don't call them high entities anymore. They're just going to be entities. So then we have an entity, right, like so. That's going to point to this guy. It's going to point to the entities that are in the region. And each time through, I'm going to advance that pointer, right? And so what we do each time through here is we just...
So I was thinking, we'll do something like this, but... And maybe I should just do it like this until we're sure we don't have to. But in my head, it makes probably more sense to do like for entity in region entities, right? And for now, I might just say, to heck with it. We will go ahead and do this way, because it's essentially what his loop is doing. I don't know why this wouldn't work just fine.
Map the entity into the low space, right? So basically what we're going to do here is, I don't know what we'll call this exactly, but I guess we'll say store entity, right? Or something like that. So we'll have load entity and store entity, I guess is what we'll call them. We'll load them out of the sort of that backend store, and then we'll store them back to it. So we're going to store this entity out, and so what we would need to know there is where we're storing the entity to. We'll assume right now that that's stored in the entity structure itself, because that seems logical, right? So we'll just do a store entity, we'll write that in a second. That may be something we actually write here. In fact, we could just say store entity. And the reason that we don't really need a function for it is because I'm thinking that, like I said, we will probably want to do it so that you literally never, ever, ever translate between high, low frequency, any of that stuff manually ever. There's just a controlled load and store. It can only happen in one place, and it happens exactly the same way every time, so it might just happen right on in here, right? So whatever we're going to call that in a second. So then we also have the same thing here, right, which is begin sim, and that, again, is going to take a sim region. Or I guess rather what it probably would do is return a sim region. So you'll do a begin sim, you get a sim region back, then you can do your sim on that sim region. When you're done, you end.
One thing I've seen in a bit of other Odin code that I've been reading lately is basically baking the result into the procedure's signature, right? So the way I would write this typically, and the way I've written it everywhere else in this code base, is just saying, we're going to return a pointer to a sim region, and that would be perfectly fine, but I could name it like this and say this is going to be my result, right? And now all I have to do is return at the end here, and it'll return a result that is a sim region pointer. I don't know how idiomatic or not idiomatic that is, but I kind of like it because it just reinforces the notion that, like, this is the thing that I'm dealing with here. This is the thing that I'm operating on. So now, like, we'll be able to assign right to that result. And it's going to start out as being nil, but this is making it explicit. And so the other thing here would be that could make this kind of a useful way to do things is that if we also wanted to return an error, and I had some error type, I don't have an error type right now that I want to return from this procedure, but we could do something like this, and then let's say we made some call, right, to a an interesting proc, and it failed, we could do or return, and then that would like propagate an error here. But we're not really, we don't have anything like that. We don't have any code that behaves that way, and so I'm not going to try and manufacture an instance where, I should try and do that, but later on it may become more obvious to me how I would structure things. But like, to me, I think this just works well enough that I do this everywhere where I'm not already doing it. I'd have to go through and make a whole bunch of changes. But again, I don't know. It seems like this would be a very intended, very much an intended use of this kind of handling of return values in Odin. But maybe that's a bad assumption. This is just something that I've seen. I haven't seen it. I've seen it in another Odin project that I've been looking at. With what little extra spare time I do have outside of the stream to work on Odin stuff. But I think I've definitely seen it inside of the Odin code base too. So I'm just going to trust that this is a a sane way to do this for now, and we'll keep working under that assumption.
Right, makes sense? Makes sense. So inside Begin Sim, what we would be doing here is we would be doing the stuff that was happening in this call right here. I like how we said do this in terms of tile chunks for it to do, which is exactly what we did.
Where was that to do? That was over in set camera, and I might have already gotten rid of it. I did not. There we go.
So what we want to do here, again, is take this code that we already wrote that just looks at sort of that region in our spatial partition. It says what are all the entities in it, and any of those entities that basically fall within the camera bounds are going to, we're going to find them, right? We're going to pull them out. And so what we can do here is say that when you do your begin sim, you just pass in that rectangle, whatever the rectangle is you're trying to sim, right? So this is the bounds of the region. You pass that to begin sim, and then that's what we use for everything, right? So camera bounds is now just region bounds, right? Region bounds, like so. And the region bounds, I guess we...
All right, and technically it's a camera when we're using it as a camera, right? Because it's the bounds of the space where the camera is looking at in the game. But if it's not, if we don't actually have a camera there, then it's literally just like a square. It's a rectangle that gives us the bounds of the region and world space that we want to simulate. Oh man, this is clicking so much better this time around. I'm sure there's some minutia in here that I'm still not totally appreciating, but it's a world of difference. I don't know. I keep coming back to this. I don't know how much of this is just because I'm doing this in Odin or because I'm doing this for a second time. Like it seemed insane, and it still seems insane to be doing things this way, but at the same time, I wouldn't be getting it quite like I am now if I wasn't doing things this way. So I can only trust in the notion that this is actually proving to be educational, because I'm not challenged in this way, right, by the daily work that I tend to have to do. I used to be, and then for whatever reason, that just kind of dissipated over time, and probably a whole bunch of reasons why that is. But this is really exciting for me to be able to kind of forge new learning, as painful as it may be and as strange as it may be to have to do it in this way. Looks like my camera, oh, there it goes. It defocused because I was being wild, I guess, and pounding on my desk. I don't know.
Need to also give you what it's centered around, because that needs to be one of those higher frequency positions, right? That needs to be one of the more specific things, right? So this is the region center, and that's the region bounds, like so. And so new camera P is just region center, right? So there we go. So we go ahead and we loop through all of these things. We find all of the entities that are relevant to us, and then we're going to go ahead and map them out. This also means that now the low entities, right, we no longer have the double pointer situation, which is really good. We no longer have low entities pointing to highs and highs back to lows. We only have entities that point back to their storage location, right? Because that's something that we presumably always want to be able to do correctly.
Okay, that does sound a lot better too, because that was really bugging me as well. Every time I had to reconcile, okay, so we have the high entity, so we know its low index and what it points back to, but we don't have the high entity index on the high entity. And then same thing with the low entity. It was like, okay, I've got this low entity, but I don't have the index to it. And so he was having to make all of these like weird shuffling changes that didn't really seem to be getting us anything. But I think it was important to see why that wasn't feeling as nice as it could have, because otherwise you wouldn't know how nice it is when you arrive at a new design that works better, right? So let's go ahead and change all this new camera business to, what is that, region center. Region center, and then the camera bounds become region bounds. And then over here, this should just be region center. And then there's the world that needs to get passed in as well. Actually, I guess it looks like we should be passing in the entire game state. Kind of jumping ahead here, but I don't want to look at these errors. So then here, we can pull the world off of the game state. And then that's looking good. We got one more reference to these camera bounds. Change that, and then instead of camera space, I suppose we'll just call that region space. I don't know. But that leaves us in a place where OLS isn't mad, but we still got quite a bit of work to do.
Right. Furthermore, things are going to get even better, people. They're going to get even better, just you wait. I can see it coming down the pipe. I can see it. Can you see it? Yeah, maybe you can't see it. Doesn't matter. It's there. All right, anyway. So if we go ahead through here, and we say, all right, we've got our low entity. It no longer has to point to the high entity because that's not relevant anymore, right? And then we no longer need this entity structure because you're only ever going to be dealing with one or the other kind of entity.
Should go in and change that. Was that on the low entity? Whoops, low entity. So on here, he just got rid of that high entity index. And then it looks like he was going to do something about this, you know, it's not really a type, it just kind of bundles all that stuff. That's all it's done so far.
I believe. I think we're going to want to do that so that everything kind of gets moved up into the high entity. I'm not sure exactly how we'll handle that for now. We're going to have to think about that a little bit more. So this will go away eventually, but I think I'm going to leave it just for a little bit because as we sort of port the code over, I don't want to go too far too fast. All right, so basically the low entity indexes, we now no longer have to check to see or anything whether they need to be moved in because everyone needs to get moved in because no one's in the state yet, right? So what we need to do is we need to be able to sort of pull those guys in. And so what we're going to do here, I don't know exactly, one of the things is when we do this begin sim, it's a little unclear how we exactly want to divide up the memory that we're using because I don't know how much we care about whether the entity array is contiguous or not. It's something that, and we don't know exactly how we're going to process these, so I'm not going to think too hard about that yet, but later on, because we want this to be relatively, we want this code to be relatively fast because once you build one of these begin sims, we want all the code that happens inside it to be fast. We may have to think about how we're going to actually place these things in memory, but for right now, I'm not going to think about that too much. All right, so we go through the entity indexes, we grab out where they are, we then have a pointer to the low, and so then right here what we need to do is we need to add an entity to the sim region, right? So this would basically add a low entity to the sim region. We'll call that, I guess I'll just call that sim for now. I'll call it sim region. Call it sim region, and that, I guess we need to do the check of the camera space P as well. So this actually doesn't need to happen, but this does, because we don't want to move it into anything that's not really in the camera region, so we'll do that. And so there we go. So that's the check right there. If it's in the rectangle, we'll add it in. And we already know where the camera space P is, so I feel like that should happen here as well, right? So that's where that is in camera space. So that looks good. So that...
Okay, so this goes away. And yeah, he's still holding on to this camera space naming, but I mean, it maps more clearly to a region space. Like this is the region in the world that we're going to map into high frequency so that we can start doing updates to their state, right? So, and then the low index doesn't change. We pull the low out, same as we did before. This check is what goes away.
Allows us to add an entity to it.
And then adding it in the region space P. Is how we get the high entity to be relative to wherever the camera is pointing, but more specifically, the very center of the region, right?
Go, add entity, like so. And I think that's about it for that function for now. All right, so add entity is going to take a sim region, and it's going to add a new entity to the end here, right? So for now, we're going to do an assertion on this, or I guess we'll do an if statement, like so. We'll do an if to verify that we have enough room. So we want to make sure that the entity count is less than how many we were allowed to store. And like I said, later we might allow this to be more flexible. We'll see how I feel about it.
Yeah, it depends on how he handles the notion of max entity count, but I feel like we should probably just operate under the assumption that we're going to get rid of that, or we're not going to use that, just until I'm convinced otherwise, because it accomplishes the same thing, you know, where we're not we're setting some arbitrary max entity count, but the reason to do that is just so that you're not writing out of bounds of the memory of wherever that pointer is to those entities. So, and yeah, so actually, yeah, entity count on the region needs to be less than the bounds of the actual entity slice before we can add another one. Okay.
Later on. But assuming we're good to go there, I'm going to do an invalid code path here as well, just so we know that it'll assert when that hits so we can see whether we're overflowing our cap. So we'll go ahead and do the fact that the entities...
I don't even know that we necessarily need this panic here either, but I guess that makes it more explicit what's going on versus hitting an assertion on the bounds check when you try to index past the end of the entities slice. So try to, or let's see, sim region ran out of entity space. That seems descriptive enough.
Sim region entities, like so. So basically all we're going to do is we're going to use a new entity from that entity list after making sure that we've got enough, entity array. And then that will go ahead and add the entity. Now we've got the low entity, the low compressed version up in here. I guess what I probably should do too.
And once again, we are having to deal with this incrementing and decrementing of a count member, which kind of makes me think that maybe this ought to be a dynamic array instead of a slice, but I won't worry about that for now. So yeah, we'll just go ahead and increment that on the same line, if it'll fit. I don't know that it will. And we do want to increment that after the fact, so that's good. This should just be region. There we go.
This should be a fairly simplistic, relatively straightforward entity. I don't know, we could call this a sim entity as well. Maybe I should, just to differentiate it. I like that. I like that a lot. So I think maybe we'll call that a sim entity. Yeah, okay, that's good. So let's call that a sim entity. And we'll
I guess I don't understand the significance of doing that. But we'll just roll with it for now. He's probably going to change it here in a second. So sim entity, and there's nothing on that type yet. We just know that one is going to come back, and this is actually going to be that result, I guess, and then we return. Is that right? No, it needs to be a pointer, right? No? What's going on here? What can we not do? Oh, because it's a high entity. Gotcha. So this changes to slice of sim entities. Makes sense. Cool.
return that from here as well. Right, sim entity. And we will grab it like that. So
yeah, I'm really liking this. I'm liking that I went ahead and tried this out. It's a little weird because then it feels like you're returning nothing, but if you just look at the signature, you know, oh, okay, this is what I'm returning. It's like implicit, right? And it's implicit in a way that is, it's basically explicit, you know, because it's in the signature. Like, it's just so, I don't know, that I'm feeling it. I like it.
So that will add an entity, but it won't do anything particular to it. I'm going to clear it for now. Like I said, I'm not sure whether we actually care about that too much to do. Casey, see what we want to do about clearing policy when the entity system is more fleshed out. But for now, I'd like to clear to 0 just to avoid bugs of that nature, because that way we know everything is always, every time you make an entity, is always cleared to a good initial state.
Again, I don't know if this is really necessary, because why would we ever have a non-zero initialized bit of memory inside of our sim region, you know, basically anywhere. Why would we ever have non-zero initialized memory? I don't know. I just will be thorough about this for now to make sure. And then I can, later on, when I can just remove that cruft in the code to see what I can just basically remove stuff like this, because there's a few other places where we're doing something like that, and I can see then whether it's really going to affect anything, but I don't think it will.
What I also could do is just clear out the whole array at startup. I don't know, we'll think about that. But anyway, so when we get new entities, this will basically give them back to us, and that's fine. So the entities get added in there. And I think that's really all we need to do for that for now. And then in the case where you've got an entity, that just gives you a new entity. In the case where you're trying to add an entity in a slightly more verbose fashion, where you've got both the low entity version, right? And so I guess, I don't know what we're going to call this. I think we're going to call this a storage entity probably, right? I know we could call it a world entity. We could have sim entities and world entities. So world entities are ones that are stored out in the world thing. I'm not sure exactly what they should be called. Sim entity sounds good to me. It's an entity that's involved in a simulation region. That makes sense. World entity maybe is the right thing, because that's what it is. We have the world storage. We could change the name of that. Instead of making it a world, we could call that like spatial part. I don't know. We're going to call it world entity for now. So we'll basically say this is the source entity, and this is going to be the depth entity. So basically we have a depth entity that's going to get received from here, and assuming that we get one, we're going to say, okay, map, or like convert the stored entity to a simulation entity, right? So I don't know. Yeah, I think stored is the right thing, because that's what I used here when I was talking about it. So I think we're going to call it stored entity. I like that. And then I can call that stored as well, maybe. Yeah, source is good. All right, so let's do it like that. And then we also know.
So I guess stored is going to be our new low type, basically. And this will also return a sim entity. Yeah, there's just something about that is far more intuitive, probably. I don't really care about like stored or world entity. I think dormant and active still kind of makes sense, or maybe stored and active. It's a weird thing to have to think about, but high versus low is just not descriptive enough, probably. And so this means we have to have a procedure group. I guess I'll wait and see, because I don't know, just looking at this, what the right naming convention should be for each of these. But we're going to have a dest, and it's going to be a pointer to the results of adding the entity to the region, and we're still missing. Oh, no, I guess we're not missing anything. Did this procedure really take no other params? I guess not. So yeah, we'll have an add entity procedure group. Just go ahead and finish doing what he's written in here. It's just not obvious to me what's going on here, so I don't want to assume what these names should be just yet.
Know here that our oops, typo. We also know here that our entity is potentially going to have a position passed to it, right? Like we did here when you're creating one out of out of whole cloth like that. We know that you're going to have a world position for him as well, right? And so that's going to that you shouldn't say world position, a simulation position, because you've already done the check to see whether you could move in, so you've already got that, right? And so basically his simulation position is just going to get set directly and doesn't have to be computed, right? So that seems like a good idea. What I could do is make this an address, do something like that, and then make this a pointer like so, and then I could say, if we know what it is, then great. If we don't know what it is, then we go ahead and build it, and that would just be doing it like this, right? Let's get camera space.
Okay, so down and begin sim. This becomes a reference, and so this would be the one that we're calling directly in there. Okay, because the result coming back from this is it's cleared out, so maybe like add cleared entity is the way to go. Or add zeroed, right? And this would be like add entity with P. I really don't know. I don't really like that. But I have to decide on something. I could be just so lazy about this that I don't even care what the difference is. I mean, I know what the implementation is, and the implementation is actually what matters. I could just say, hey, we have add entity 1 and we have add entity 2. Just write the procedure group and call the one that you care about, right? That might be just the most shameful way to do this, except it could be so dumb that it's brilliant. I don't know. But those names are simple enough that I can come back around and add more descriptive ones if I really care to. But I mean, like, if you saw that convention being used everywhere for procedure groups in a code base, you might just kind of naturally conclude, oh, that's just, you know, wherever you see a procedure group, you've just got like kind of it's almost like an identifier, right? Like these are almost like IDs for each individual procedure that we're kind of overloading, right, with this one procedure name. What happened here? Was that did I call that? Did I not even add that sim entity? We didn't add it. I guess I don't know if he's going to replace low with stored. And then back down here. That actually wasn't right. If, I see. So if the pointer to the simulation position is not nil, then we do that. That's right. That's why we made that parameter pointer. And then otherwise, we just set the entity's position to whatever the camera space result is from the low entity's position. So you just beam them into the position where you want them to be, you know, being made active, or otherwise it'll just kind of infer it from the low. But where did the low come from in this case? I don't know. But he's not done, so I'll let him finish.
Now the problem is, the camera space P is actually not what we want anymore either, because we don't have a concept of a camera anymore. I mean, we do outside of this, but the sim region itself basically tracks where it thinks it is, right? It's got these two parameters baked into it, right? There's the region center and the region bounds, like that. All right. Excuse me. So we want that to actually be, we want the region center and bounds to actually be the things that are used, not any kind of a notion of a camera. So get camera space P really should never be happening anymore. Get camera space P is just a special case. So we want to kind of get rid of that and say, all right, instead of get camera space P, what we've got here is something else. We've basically got something that's like get region space P, if you will. So we have get region space P, and that just takes a sim region, right, like so.
Okay. So, and what does it take? He hasn't changed the arguments yet, but we can go ahead and rip that out and throw that, yeah, I guess just underneath here. Or Yeah, underneath here is fine. Call it region space P, and it takes that region, like you said. And what else?
And it takes whatever that stored entity is, and that will do the conversion. So it does the diff, it does that subtraction. We're going to need the world pointer here, so I'm going to assume that the
Okay. So that answers that. This will just be the destination. Well, this gives us back a sim entity. Is the stored entity on the sim entity? I guess we haven't gotten that far yet. But that parameter has to come from somewhere.
the sim itself, the sim region will store a pointer to that world, so it can grab it. It will go ahead and use its P now, right? It's what do we call that? Its center, right? Or let's use the word origin, because that's kind of a little bit better. The origin of the sim region, and that should basically give us what we want to have happen. So there we go. We'll need to store again in the sim region. We'll need to store the world so that we can get back to it. So when we call begin sim, we're going to need to use that world parameter here, right? So we're going to have a sim region world. We're going to have to set the sim region origin equals origin, sim region bounds equals bounds, like so on.
Okay, so going back to this, calling it region whatever is redundant. Center becomes the origin. And rather than passing in the game state, we're actually just going to store a pointer to the world in the region itself. I guess it doesn't really need to know about the rest of the game state, so that's fair. What is going on here? There is no P. What? Well, yeah. Yeah, we're not quite there yet. But down here, this is just wrong. Or, yeah, so this should have always taken a pointer to the world. And then, what is he changing that to? Origin? Yeah. So rather than naming those like so, we do that. And so the result will actually just be assigned here, at least parts of it. I'm trying to think of the most ergonomic way to do this. But I think just like this, right? Cannot be used as a compound literal. What? Where did I go wrong? Oh, duh. Region doesn't exist, but result does. Okay. Okay, let's see. Let's keep seeing where this goes. I don't know if we'll be in a working state by the end of the day. We have roughly 20-something minutes left, so we'll see.
Lovely. So that looks reasonable, right? And now we have like get region space P, which is exactly what we want. So we can pass the sim region to it, and it'll get us region space P. And down here, that same thing can be used instead of camera space P. So now this can just use sim region origin. So sim region origin, and then min corner for the sim region bounds. Okay. And similarly in here, we should be able to do sim region origin, and this should be get region space P, and that should be able to take the sim region there, and this is sim space P, right? What did I actually get region space? It really shouldn't be called region space. It should really be called sim space, probably, right? Sim space P sounds a little bit better. So let's say.
I guess I hadn't considered that. So, sim space P. rather than region. It's shorter, and so I have no choice but to be okay with that. And this should just be sim space p. I take it. Sim space p. And then over here, I guess I don't actually know if he's going to change that procedure call name, but whatever. So this is region origin, right? And then region bounds should be region, yeah, like that. And this should actually all be off the result, not this region. This is the second time I've done that. That's just that, and oh. Yeah, we're definitely going to need the game state still. So that was premature to say that we wouldn't, but that's okay. We can bring that back. And that just needs to be an access. And I think we're pretty much there.
Get region space is going to get sim space. Like that a little bit better. All right. So that seems good. Everything seems reasonable there.
Sweet. So we did change that procedure name. Get sim space p. Yeah, because it's the space that we're simulating in. I'm cool with it.
Lovely. And so what we're going to need now is, I guess we're going to need to sort of just do some sort of smushing here to smush everything back into a reasonable state. Here's the stuff that we know we needed before on here. So this will be a storage index, and this is basically something that tells us where this entity came from, right? This is all relative to the sim region.
All right, back in our main game code, we go and look up that high entity type, and all of this is coming off of there. And it's going into, well, I guess I shouldn't delete it quite yet in case, I don't know. I don't know what in case of. I just, I hate prematurely deleting things because it tends to cause me problems. And then the sim entity type gets all of that now. And then this low entity index, like you just said, becomes a storage index. But we want that to be an int, so I guess I'll just leave that right there.
We don't need to comment that really as much anymore because now it's much clearer. We can put some comments at the top potentially to talk about that a little bit more. And so there we go. Now, our T-Bob is an animation thing that I don't think we want to have anymore. But what this does mean very clearly, and this was sort of something that probably should have happened originally anyway, which is that velocity is now something that has to be stored across frame boundaries, obviously. Velocity is something that has to be stored in the low entity as well, right? So in the low entity, in order for things to persist, we need to keep that velocity around. So that's going to go in there. High entity basically goes away entirely. That's just gone.
Okay. So we would have been safe to delete that, but now we know for sure. But the delta p will go on the low entity, and it doesn't have a vector 2 anywhere yet, so don't need to mess with that code much. Just get rid of that.
So our sim entity has this information in it, yeah, that it wouldn't otherwise have needed. Same with the facing direction, and even I guess T-Bob for now can go out into the low entity. Because the low entity is really where we're going to be focusing all of our attention in terms of splitting things up anyway. So that seems pretty fine. Pretty.
Okay, so we got to move that out as well. So on here, where do you put that? Just tends to be easier to find things if I try and put things in generally the same place. He also took the facing direction off. I don't know if he meant to do that. But I guess I'll see if he changes it, and if he doesn't, I should go ahead and do the same thing.
So we got our Z and DZ. This chunk Z, this stuff we're gonna have to clean up a little bit because we did add vector 3s eventually, but we've never really quite gotten around to handling Z in a logical way. We're gonna postpone that for now again because one thing is that. So that's all good.
Just want to make sure he didn't change anything there. So if we go back over here, facing direction can go up there, or we can actually throw that over here. Sure.
Because one thing at a time. So that's all good. Now what we need to do is start actually making this work a little bit more straightforwardly by cleaning up the code that we do have and making it work within these confines. Now, one thing that I do need to do is I need to be able to actually allocate one of these sim regions, right? And so what I'm going to do is I'm going to, for the first time, introduce the concept of a transient of the transient stack, basically. And so that's something that I think we probably won't have time to do today. So I'm just going to leave it as a placeholder, and then we'll do it tomorrow. So if I go ahead here and I say we've got our memory arenas, right? I'm going to say that we'll have some way of doing this a little bit more fancily in tomorrow, basically. So we're going to say here that we basically have a memory arena, which is the sim arena. And later on, we're going to have a more stronger notion of where that's coming from. For now, we're just going to use that. And so from the sim arena.
Okay, so now things are going to get a little bit more interesting. I'm going to have to think carefully about this, but we're not going to pass in an arena. Instead, we'll pass in an allocator to a sim, or we'll pass in a pointer to a sim allocator, right, rather than a sim arena. And I don't know if we really need to be that descriptive about it, but yeah, this should just be probably mem allocator, something like that. And that means we're going to have to import the mem package. Yeah, it's going to be interesting because using a different arena for the transient storage, in this case, the for the sim stuff, I'll just have to see how this shakes out, but it could require me spending a good amount of time off stream thinking about how I want to handle this, because we only have one context allocator, and this would suppose that we're going to, but it's basically like a temp allocator, right? Because it's transient. I think that's the case, in which case we may be able to just use the temp allocator without even doing anything else. But what we would say is that the temp allocator is using the transient storage, and we would say it's a virtual arena, just like the one we're using for the permanent storage. I think that's how we'll probably want to do this, but I need to sit with that and make sure that that'll look okay.
We are going to allocate the space that we need to store the simulation system. So what we need to do here is we just need to do a push struct, right, on the sim arena, excuse me, to push our sim region.
So the equivalent of doing this, right, would be, make one new sim region. And we'll use the sim allocator, which could very well just be the temp allocator. I need to understand the temp allocator better here too, because I don't know like at which point it's being reset. I assume, yeah. Yeah, I shouldn't assume anything right now because it's been a while since I've looked at any example code involving use of the temp allocator. Man, my voice is really going. So, yeah. I mean, we could just call it temp. I don't know. We'll just stick with sim for now. And what is the problem here? Oh, because it needs to be a reference to it. Is that right? But I thought it was, I mean, it's a pointer, so how is it not? Huh. I guess I have to dereference it. Is that true? Results must be handled. I think then we can say that. No? Oh, because it's the pointer that gets returned, so it's just that. Okay, sweet.
Like so. We need to initialize that sim region. We need to initialize the entity bounds for that, right? So we need the entities, sim region, max entity count. We need the entity count itself, which we want to start at 0. And I'll go ahead and move these into the order they're actually in. So it's world, origin, bounds, max entity count. So the max entity count for now, we'll set as something high to do. Casey, need to be more specific about entity counts. In fact, this could actually be very high because this is a transient processing thing. We could really set this extremely high because we're using a very large scratch space basically. So we could think about that a little bit later. How exactly we want to deal with that process basically. And then our entities, we should. There was, I believe, was there already a push array? Yes, there was a push array. So what we can do is we can go ahead and get our array of entities as well. So there we go.
Okay, let's see. So the max entity count is 4096. And then we have this to do in here about needing to be more specific about entity counts and like what is the default, right? Probably the default number of entities that we want to have simulated per region. So then this is just going to be a make, and it's going to be of sim entities, and we're going to have 4096 of them. So probably want to change the way I am doing these assignments then. What? Well, yeah, we don't need that. So actually, never mind. This will look fine, I think. No procedures or, oh, because I need, well, I don't know actually. I think I do know that I need to pass in the sim allocator. No procedures or ambiguous call for procedure group. Make that match with, okay. How did I do this before then? Oh, is it because I need to say it's a slice of them? Yeah, I think that's right.
The count is going to be that max entity count, right? And then the thing, it is a sim entity, right? So that grabs all of those entities. And then when we're done here, what we'll basically do is, we'll assume that this arena releases the memory that we've used. So we basically grab all the memory up front, we do all the processing, and then we push it away, if that makes sense. And we'll have to deal with that later. So, there we go. When we do our endsim, we just need to store back to low, which at the moment, I guess we can actually implement because we already have the code for it. It's a make entity low frequency, right? That's this code right here. And so if I just go ahead and add that in, we can just grab the parts of it that we wanted. Essentially, we already...
Okay, so I have to go ahead and do that. There's still all sorts of errors going on here. Like we still need to pass in the game state or otherwise figure out a way to get the low entity out. Oh, and then this should be result. So we can actually fix those real quick. So that just leaves the game state thing. Yeah, I feel like I'm just going to have to change that again. That's like the 3rd or 4th time. No biggie. And so this code here came from make entity low frequency, which I think was in the main game code. Make entity, well, let's make entity high. What about make entity low? Make entity low. So we'll just go ahead and rip all of that out and throw it in this loop. And keep on chugging along. Pretty much out of time here. I guess we'll see how much more of this I can get through before I have to call the stream. Maybe I'll get to finish, but probably not.
We know what we already know that we don't care about the high frequency index at all. All we care about is the low frequency index, right? And so that low frequency index is going to be whatever was in the storage index right here, right? So we basically have that entity storage index tells us where this entity is going to go. You'll have to excuse me, I'm still sick. As on.
This doesn't seem right. What's going on here? Oh, okay. So that you still have this old debug code in there, and that just kind of threw me off. But what's interesting is did he have... Okay. So this goes away. And that goes away. And this, because we only care about the low index, is that right? Yeah.
And so that low frequency index is going to be whatever was in the storage index right here, right? So we basically have that entity storage index tells us where this entity is going to go. You'll have to excuse me, I'm still sick, as often I am on stream. You can't stop programming just because you're sick. You gotta power through. I mean, if you're really sick, then don't program. If you're really, really sick. But you know, I'm certainly well enough to program. Let's put it that way. All right, so I grabbed my entity here. Let's take a look at this here. We've got the region entity count. We're going through the entities. That's exactly what I want. We have the storage index. So the storage index is basically going to put these back into that low entity array, right? And so where we have that was actually in the game state, which is not necessarily where I would like them to be. I think those maybe would be better served now that I think about it in the world, but we can talk about that later. Let's see. To do. Maybe don't take a game state here. Low entities should be stored in the world. Something like that. But for now, we'll go ahead and do that.
Okay, so that would solve that issue I was having, constantly going back and forth between passing in the state of the game, of the entire game, or the world. If the world has the low entity stored on it and the game state doesn't, then you don't have to keep passing around that game state, right? So don't take a game state here. Low entities go in the world instead. And there you go.
So in order to get the low entity out, right, we've got the low entity, which we're going to change the name of, I guess, to stored entity, right? So the stored one is going to be the game state, stored entities for now, something like this. We're going to go ahead and grab those out, like so. You know what, I guess before I change the name, I guess I could do stored entity is just still low entity, just to make the porting a little easier at first. And we'll just make that a to-do. To-do, Casey, change the name, stored entity.
Okay, so back on the state struct is where we're going to throw that down. To do change the name to stored entity. And then back in the sim region file, anywhere that we had a reference to a stored entity, which I actually don't think, it's like in two places maybe, stored entity can go become low. Yeah, two different places, but maybe that just fixes a whole lot of nonsense. So game state. Oh yeah, well, that's on the region now. That's right, because we added a world pointer to the region, or a pointer to the world on the region, I guess. And then this should be a dereference. Or no, that should be a dereference. And then get region space P. What does that take? Get, oh, it should be sim space. And then what is dest? Is it because I don't have that as a pointer? Should that be a pointer? It is a pointer, isn't it? Oh, it's a high entity pointer. So that's wrong. Yeah, I don't know. I guess we'll see if I did something wrong there, or if Casey still needs to make some changes there.
All right, so we grab the stored entity. We don't care about this, that's in debug code. We don't care about any of this. So I guess we didn't, in that code, we didn't actually do the packing there. In make entity low frequency, we didn't actually ever update that code. So this is just kind of garbage code, really. It doesn't even work anymore. So that's no good. Validate entity pairs goes away because entities are no longer paired in that sense. Use only a pointer back in one direction, so they don't really get validated. And force entity into high doesn't make any sense either.
So he's nuking a whole bunch of stuff right now. Force entity, what was that? Into high. Yeah, he got rid of that. Sure, why not? I think it was the make entity low frequency call that you were just talking about. So that is all going away now. And then, what was it? Validate entity pairs is going away. We'll see. I don't know. I'm trusting, I'm trusting that he understands already why those aren't necessary anymore. But I can't even remember what we were doing. Well, the validate entity pairs make sure that the entities are pointing back at each other correctly. I get that, but I didn't know all the places that we were using it could just be wiped off the map. But I guess just because of this design change that's being made, right, we don't have to think about it in those terms anymore.
Offset and check frequency by area we got rid of because we now have that that concept. You never actually do move things out, so that's fine. So that goes away. So that's good. Make entity high frequency we already essentially did. It's the camera space P part, which is done, so that goes away as well. This is the part that we actually, well, no, we don't need that either. Yeah, we don't need that either, really, because we've already replaced that entirely, as well as all of this. So yeah, so that's good.
Wow. So all of this is going away too. This is crazy. That a design change can force that much code to be obsolete just like that. Not a typical experience for me. But I think that's just because the problems that I tend to deal with are so simple that they don't necessitate having to do anything remotely complex as far as like a solve that then can be distilled down into something simpler. What even is going on here? Entity hit point max. Where did that go? Cannot assign what? You know what? I don't know what your problem is, but what? Yeah. I don't know. Who cares? We're not even dealing with that right now.
We don't really need any of this. All goes away. It's all toasted at this point. Add familiar. So what we need to do now is it's this part right here. Change entity location is really the...
Looks like you got rid of a bunch more code again. Is it just the get low and high, or get low and add low entity stuff?
All of this. So yeah, so that's good. We don't really need any of this. All goes away. It's all toasted at this point. Add familiar. So what we need to do now is it's this part.
I can't even tell what he did just there, so I guess I'll just wait until it's obvious that that code isn't needed anymore.
Part right here, change entity location, is really the part that we care about. So that was the thing that I was looking for this code to give me, and it turned out that code had nothing to do with it. So what I want to do here is, as we spin through them, this is the part that I actually need to update. We have a to-do here, which is basically like, you know, save state back to the stored entity. But right now, once high entities do state decompression.
Where was that call? Was it right here? I think so. So we take that, we go back into the sim code, and all of this that he thought, like he was saying, that was going to get used here is irrelevant to what's going on. What are we doing here? We are going to pull... Oh, that's weird. He didn't change that. I thought he was going to stick to low, but maybe he just missed that that change. This right here says stored entities for him, but I thought he said he was just gonna stick to low everywhere, so we're not dealing with making that change everywhere else in the code. But okay, so we use the stored index to get the stored entity out, and it has to be a pointer. And then, like I said, we have this to do to save state back to the stored entity once high entities do state decompression. state decompression. That sounds fancy. And then over here, gamestate.world gets us that, and then I don't know about the rest of this.
But for right now, I suppose we don't really have that. Now, maybe what we could do is we could say that all of the things exist in the sim entity as well. That's kind of an interesting idea. I'm not sure we want to take that step yet. So we'll just say that that's going to change a little bit later on. All right, so when we change entity location, we pass all the same stuff to the game state. And now this right here is that stored index. So this is the storage index of the entity, right? We have that low version of him. We know where he is because that's just that. And then we have his new position is basically going to be whatever we derive from that, excuse me, from that chunk space.
Whoa, okay, so that just becomes stored, that becomes stored, and then this is just the stored position. Undeclared name. Oh, I did not actually declare it. Whoops. So that's fixed, and then the new P.
Mapping. So what we'll do is we'll take that new same set of calls here, and now it's not going to be the camera's location anymore. Again, it's the region's location that we're mapping around, and then we have that offset from that stored in our entity, which is just the P. So that just works, right?
Yeah, already that is looking so much better because now, like, we just know based on the context of what we're doing, whether we're dealing with a stored position and or an active one, a stored entity or an active entity, dormant entity or a active entity. Like having to do this stuff, right? Having to call low or high, and then you got to know like what position do I actually want to be passing in here? Like all these things that just kind of obfuscate what the actual thing it is that you're doing in that code. Don't have to deal with that anymore. So, and then this takes the world. Right.
Okay. So, that all looks good. Pretty straightforward. Pretty straightforward. So that's good. And now set camera pretty much doesn't do anything, if I'm not mistaken. Let's take a look. So basically, we don't need to do any of this. We need this in some. We need to save just this concept of how big the camera was. So I'm basically going to move that into. I'm going to save just this piece, right? Like so. So we don't need this. We don't need any of that.
So now we're doing all these updates. Oh, what happened here? So this is still entity. Yeah. Right? No? What's going on there? Low entity index. Yeah, what the heck? Entity storage index, stored. What did I make this? This is an F32. I see, yeah. Because we got rid of the facing direction, that type just got changed incorrectly. Oh, and then the set camera stuff needs to change now. So if we go back into the game code, over here, I think he got rid of, or maybe he didn't get rid of this already, but we got rid of that procedure, so probably safe to just get rid of that. And this, he said, moves up here, right?
I'm going to move that into, I'm going to save just this piece, right? Like so. So we don't need this. We don't need any of that. We don't need this anymore. We don't need this. So really all we need to do here, this will be some kind of function, basically where we...
Holy crap, he just toasted all of this code. Oh, there wasn't that much. What? Yeah, because that call is gone. This just doesn't happen anymore. I don't even remember removing all of that code in between here and here. Well, I guess we did that yesterday. Is that right? No, we did that today. We did that at like the beginning of the stream, which is when we took, yeah, all of this stuff out. Okay. Yeah, that is that's pretty awesome. It's like hard to even articulate why it's awesome, but it feels a lot better. Feeling excited about it.
Excuse me. This will just be some kind of function where we actually do our begin end sim. So it'd be something like, you know, sim camera region or something like this, right?
Actually, it looks like I got rid of something here that I was supposed to hold on to. Yeah, the camera bound stuff. What did I do? That's weird. Didn't mean to delete all of that. So, yeah, that goes away. This goes away. All of this is gone. And then this new camera piece stuff, I don't know if that's going to hang around. Well, yeah, I suppose it has to.
And we wouldn't actually need a new camera P. We would just go ahead and say, all right, take the game state, figure out how big we want that camera bound to be, and then just go ahead here and do the...
Oh, okay, yeah, because we're making this generic. I did not even catch that he changed the name of that. So sim camera region. And then I'm guessing this will just get thrown into the sim code. Get rid of that.
And sim pair, right? So it's going to be like, oops. It's going to be like, all right, you know, here's our sim region. Go ahead and make it. We don't know exactly what that region is yet, but that's fine. We've got the world, and we've got the origin's going to be the camera. So this is the camera P, right? And then we've got those camera bounds that we just computed. So this is the region we want to sim. We go ahead and do that, and then we'll, you know, write some code in there for actually simulating the entities, which we haven't quite done yet. And there we go. So that's all we really need to do now. So sim camera region we just collapse down. We could probably just move this whole thing.
Don't know. Yeah, because this is going back into this issue of like, where is this allocator going to come from? I don't really know. My hunch, though, is that we will overwrite the temp allocator with a new virtual arena. We'll try to anyway. There could very well be an issue with me trying to do that, but can't worry about that right now. So that takes in, yeah, because the camera, that the camera position on the game state is the one that we care about. And then we've just calculated the camera bounds based on the stuff here. So yeah, that just works. And then I don't know, I guess we'll just, for the moment, take the context allocator off. Or I wonder if it should just be a reference. Well, that wouldn't work because I'd run into the same problem that I had before, right? Yeah, I cannot do that. So we just do that instead. Now, what else am I missing here? So this is the origin, the bounds. I didn't pass in the world for some reason.
Back down into the main game loop. It's not really even a function anymore for all intents and purposes. So really what we got to do now is just that, right? We just do that right here. Nothing fancy about it. There's our sim. And then when we...
So he's just going to do that outside of that branch. Okay. All right, man. Uh-oh. Well, I think I've just hit my hard stop. I can hear things are happening elsewhere in the house. So I will simply say thanks for hanging out with me on stream, and that I'll be back tomorrow where I'll have cleaned this up and finished the code out. There's only like 5 or 6 minutes left, so not the end of the world. We got pretty close to done, and really all I'm doing at this point is just trying to get to where Casey is trying to get, which I think is just going to have the project compile. I don't know if it'll actually work, but if it does, we will find out in tomorrow's stream. So thanks for hanging out with me on another stream of Odinmade Hero. We'll be back for day 64 tomorrow, where we will map entity indexes to pointers. And it sounds like really just keep on fleshing out this idea of simulating different regions of our world and kind of just arriving at this more neat design where we don't have to think about this high versus low stuff all the time. See, like stuff like this, I think stuff like this will just kind of go away. So yeah, have a good rest of your day, and I'll see you in the next stream.